Okay, guys, so we're going to take notes on the atomic structure today. This is probably one of the most important concepts that we are going to go over throughout the entire school year. STAR absolutely loves to test on the atomic structure, so I need to make sure that you are taking very good C notes. Do lots of drawings to help you understand the parts of the atom. And any questions that you have about this video, make sure you write them in the left-hand column and you ask them to me tomorrow. All right, so when we talk about the atomic structure, the first thing we have to talk about is what is an atom? Well, an atom is the basic building block of matter, pretty much meaning it is the smallest part of an element. Everything in the universe is made out of atoms. You, your hair, the air you breathe, the water you drink, the food you eat, everything is made out of atoms. The different types of atoms that there are is an element. So the definition of an element is a substance that cannot be broken down to create a new substance by physical or chemical means. All elements in the universe can be found on the periodic table. So you can have the element carbon, which if it is an element and it can't be broken down, means that every atom in that element is a carbon atom. So atoms make up elements, but they have to be the same type. And then, of course, if we're going to talk about an element, we need to go into a compound. So a compound is two or more different atoms that are bonded together. A molecule is two or more atoms that are bonded together. So a compound can actually be considered a molecule, and this can kind of get confusing. So if you have two nitrogen atoms that are bonded together, like N2, that is actually an element, but can be classified as a molecule. If you have one nitrogen and one hydrogen atom bonded together, because they are two different elements, that would be a compound. All right, so let's talk about the three subatomic particles of an atom. You are going to have to know these, and this is pretty much what the TEK says, is that for every subatomic particle, you need to know these three things: the charge, the location, and the mass. So let's talk about the proton first. The proton is probably the most important of all three subatomic particles. A proton is a positively charged particle that is found in the nucleus of an atom, and it has a mass of 1 AMU. So those are the three things: positively charged, found in the nucleus, and has a mass of 1 AMU. Now, the reason why protons are probably the most important subatomic particle is because of this right here. Protons identifies an element. So every element has a unique number of protons, just like every person has a unique fingerprint. So hydrogen has 1 proton. Helium has 2. You cannot ever gain or lose protons, because if you gain or lose protons, you change the element's identity. So if you have hydrogen that has 1 proton, you add a second proton to it, it is no longer hydrogen, it is now helium, because helium will always have 2. All right, the second particle we're going to talk about is an electron. An electron is the opposite from a proton in almost every single way. Electrons are negatively charged, and they're not found in the nucleus. They're actually found in an area around the nucleus, which is called an energy level, which is located in the electron cloud. And because electrons are so tiny, we consider them to have 0 mass, because an electron is actually 1/1600th that of a proton. Now, if you'll notice up here, I said AMU. That stands for atomic mass unit. So when scientists found out that they're protons, these things were so small, they had to create a mass unit for it. Well, now here all of a sudden, we have these electrons, and I'm telling you they're 1/1600th that of a proton. That is so small that we just consider them to have 0 mass. Now, there is a special type of electron, which is called a valence electron, and this was definitely one of our need-to-knows. A valence electron are only the electrons that are found in the outermost energy level of an atom. And the reason why they are so important is because they determine reactivity. meaning they determine how an atom is going to bond with other atoms, and if it even is. So just like protons determine identity, valence electrons determine reactivity. And the third and final subatomic particle is a neutron. Now, a neutron is just like it sounds, a neutral particle, meaning that it has no charge. It is also located in the nucleus, and it has a mass of 1 AMU. So I want you to pause for a second and think about a proton and a neutron. They both have a mass of 1 AMU, and they are both found in the nucleus. The only difference between them is protons are positive, like PP, and neutrons are neutral. So NEU, NEU. All right? So go ahead and pause the video if you need to finish writing this down. Okay, so I actually want you to draw the picture of this atom. This is what an atom looks like, and we are going to label the parts and the subatomic particles. So notice that we have 3 different colors. Each color represents a subatomic particle. So the fourth forgotten feature that everybody tends to forget is that most atoms are mainly made up of empty space. Now, if this big cluster right here in the middle is the nucleus, and these rings are what we actually call energy levels, which are found in the electron cloud, all this between the two is empty space. So everything in the universe, everything is mainly made out of empty space because everything is made out of atoms. So let's go ahead and draw this. You are going to need some colors so you can label them. So this very first thing right here, this is an electron, okay? So the green are electrons, and you can tell that they're electrons because they have this negative symbol in it. Not only that, they are located around the nucleus in the electron cloud. Now, if you wanted to be technical, this is actually a valence electron because it is in the outermost energy level. So when I talk about energy level, I'm talking about the outermost ring. Protons are the yellow, and we can tell that they are because they're positive and they are found in the nucleus. Neutrons are blue, and notice they don't have a symbol in there because they are neither positive nor negative. They are neutral, and they are found in the nucleus. So that means this cluster must be the nucleus. Okay, so go ahead and label these parts. You could go ahead and label this as an electron, and this is a valence electron, and this is an energy level. All right, so let's talk about an atomic symbol. What information does each of these provide? Well, it actually gives you a bunch of information. And the first one is the atomic number. On the periodic table, the very first number that you see, for example, for silicon right here, this 14, is called the atomic number. The atomic number is always going to give you the number of protons and the number of electrons of a neutral atom. Now, the reason why I say of a neutral atom is because when you get to high school, it will change. So if you look at silicon, for example, you can tell that silicon has 14 protons and 14 electrons because its atomic number is 14. So now let's look at the atomic mass, which is the second number under the symbol. The atomic mass number is the mass of the atom, pretty much meaning it's the mass of the nucleus. Because remember what I said about those pesky electrons? They are so small that we consider them to have zero mass. So when you're actually looking at the atomic mass, it is just the protons plus the neutrons. So it's the protons and neutrons added together. And so when you look at this, you will always take the number and round it to the nearest whole number. So if silicon has a mass of 28, then that means, and it has 14 protons, then take 28 minus 14, and that figure helps you figure out how many neutrons there are. So looking at this information, just by looking at these two numbers, I can tell you that it has 14 protons, 14 electrons, And then taking 28 minus 14 is 14 neutrons. So by looking at these two pieces of information on the periodic table, I can tell you the number of every subatomic particle. That's pretty cool. So let's talk about a way to remember this is APEMAN. Now here it goes, the very first thing. From now on, anytime you have a quiz or a test, I expect to see APEMAN written on your paper. And the reason I'm going to get crazy Nazi about this is because it will help you answer these questions. All right, so let's tell you what APEMAN stands for. APE is where you have the atomic number is always equal to the number of protons, which is equal to the number of electrons. So that's what APE stands for. So for example, if I told you I had this element and it had an atomic number of 5, then how many protons does it have? 5. And how many electrons? 5. They will always be equal. So now let's go to the MAN. The MAN stands for mass number, which is this one right here, subtracted from the atomic number, this one at the top, will always give you the number of neutrons. So there you go, APEMAN. Atomic number, this one right here, gives you protons and electrons. And then you take the mass number, subtracted from the atomic number to give you neutrons. Once you have figured out the protons, neutrons, and electrons of an atom, you should be able to draw it, replicate it, or answer any question about it. Okay, so let's do one more practice with lithium. So look at lithium's atomic number is 3. So that means it has 3 protons and 3 electrons. Looking at its mass number, now it's 6.9, which rounds to 7. So what is 7 minus 3? 4, meaning how many neutrons do we have? We have 4. Okay, so if you need to rewind the video at any time, please go ahead and do so. Practice figuring out the number of protons, neutrons, and electrons. You do have a periodic table glued into the back of your journal, so you should be able to look at that. And tomorrow we will answer questions and go a little bit further. Have a good night.